Okay, I think we're recording. Share my screen. Sketchbook. Okay, so now we'll do some examples. This is from the textbook, homework problem number 6, which was not assigned because it's even. But how similar do you think it's going to be to problem number 5? Probably very similar. Okay, it shows two integrals. Integral of 5 times, I'm going to do that a little better. 5 times 6 plus 5x to the 10th dx. And it also shows integral of 14x squared times 2x to the 7th plus 9 to the 6th dx. And we want to know which ones of these can be integrated, because sometimes the function is not in a form that you can integrate it, and it's really tough to do. And you got to find another method to do it, or you have to do numerical integration, which is a whole different ball of wax. So we're going to look at these one at a time. And here I see this, a function raised to a power. So I think power rule. And I'm going to let u equal 6 plus 5x. And then du is going to be, what's the derivative of this? Let's see, 5x derivative of that is 5. So do we have a 5 times dx up here? Oh, look at that. We got a 5 times dx. This one can be differentiated. So the answer to question A, which one can be differentiated? This one can, yes. Yay. Let's look over here. Here's a function raised to an exponent. Let u equals 2x to the 7th plus 9. And then du is going to be the derivative of this is 2 times 7 is 14. Ah, nice, we got a 14. So it's 14x to the 6th dx. Do we have a 14x to the 6th? No. We got a 14x to the 2nd. We don't have an x to the 6th. So if the 14 wasn't there, we can manage that. We can get more constants in front with some tricks, and I'll show you. But we cannot add more variables. So this thing, we cannot do the integration with the power rule. We would have to come up with some other method. It's possible it can't be integrated. Or we'd have to, probably we would have to expand this out to the 6th power and do that really ugly FOIL process. And then we could do it. So over here, let's go ahead and do this integral. So I'm going to rewrite it as 6 plus 5x times 5 dx. So here's u and here's du. Whoops, to the 10th. So this will be u to the 11 over 11. So that would be 6 plus 5x to the 11 over 11 plus c. So this is how we would use the power rule to solve this one. Okay, just like number 5 on your homework. I'm sure you all just can't wait to get to the homework. I know it is fun. Okay, here's example 3 out of the textbook. Integrate the square root of 2x plus 3 times 2 dx. Notice the 2 is not under the square root sign, it's outside of it. So first of all, we're going to rewrite this. 2x plus 3 to the 1/2 times 2 dx. Function raised to an exponent. Let u equals 2x plus 3. du is going to be, let's see, the derivative of 2x is 2. Derivative of 3 is 0. Okay, there we go. Do we have a 2 dx? Oh, look at that, we do. So I can go ahead and write this in the form u to the 1/2 du, and that's going to become u to the 1/2 plus 1 is 3/2. And there's our fraction in the denominator again, which we don't enjoy. So I'll flip that over right now. That's 2/3 u to the 3/2 plus c. And now let me substitute in for u. So that's 2/3 times 2x plus 3 raised to the 3/2. There we go. Boop, done. Any questions? Of course not. Okay, let's do another one so you can start seeing the pattern. It's the trick with the power rule is you gotta do a lot of problems so you can see the pattern. Okay, so this one, this is example 4 in your book. Ah, go away. So it's the integral of x cubed times 5x to the 4th plus 11 all raised to the 9th power. Okay, oh, function raised to an exponent. Look at that. So 5x to the 4th plus 11. What am I doing? Let me go back. There we go. Let u equals 5x to the 4th plus 11. And then du is going to be the integral of this. So that would be 4 times 5 is 20x cubed plus the derivative of 11 is 0. So dx. 20x cubed. Do we have a 20x cubed here? We got an x cubed. That's good. We got the variable. We got our dx here. We don't have a 20. So I can put a constant in. I can multiply this by 20, but I can't change the value of the integral. So I have to also divide by 20. So I multiplied and divided by 20. That's the same as 1. I didn't change the value of the integral, but now I have it set up so that it looks like our formula. So this is 5x to the 4th plus 11 to the 9th times 20x cubed dx. Now we're in the form of, we got to leave that 1/20th. We can't forget about it. This is in the form u to the 9th times du. And that's going to be u to the 10th over 10. Okay, 20 times 10 is 200. U is this guy right here. I'm going to plug that into u. So this will be 5x to the 4th plus 11, all raised to the 10th power. There we go. So this is an important trick. When we don't have the coefficient we need for du, we force it to be in there by multiplying it in, but then we divide it out as well so that we didn't change the value of the integral. Very, very important. Okay, and let's do one more. Example 5. I don't want to have these videos go too long and have it destroy your data program if you don't have unlimited data and you're using a cell phone. That can be pretty nasty. So let's see. This is 5x squared times x cubed minus 3 times dx. Dx can never be inside a function. It can't be underneath the square root. It's always on the outside, but it's always inside the integral. Okay, so first thing, rewrite it. So x cubed minus 3 to the 1/2. Function raised to an exponent. Whoops. Let u equals x cubed minus 3. Then du, this will be 3x squared. Integral, the derivative of 3 is 0, dx. Okay. Well, we got an x squared, but we don't have a 3x squared. So let me pull the 5 out of the integral to get it out of the way. And now I want to force a 3 to go in here. But if I add a 3, I have to divide by 3 as well. So now I have 5/3 integral of, I'm going to write this stuff first, x cubed minus 3 to the 1/2 times 3x squared dx. Now I have my differential for u, and I have my function of u in here. So I'm going to rewrite this. Got to remember to keep that coefficient here. This is what people forget, is when they get stressed, they'll forget about that coefficient and it just kind of disappears and drifts away, and that's bad. U to the 1/2 du. So 5/3. 1/2 plus 1 is 3/2. Oh, there's our little fraction in the denominator. So I'll rewrite this as 5/3 times, I flip that over, 2/3. Running out of room. Let's go upstairs here. So 5 times 2 is 10. U is this to the 3/2 plus C. There we go. Again, I can't stress enough, this is probably the most important part, is getting your U and du so that you know what you're looking at, so you know if it can be solved or not. Let me go ahead and stop this before it blows up your data program, and I'll see you on the next video. We have 4 more examples to do. It's worth sticking around and seeing them.